the sampling distribution of p hat. Let's see how sample proportions behave. When we have a binary response variable, each observation falls into one of two categories. For example, a person is either a smoker or not. A patient either survived 5 years or didn't. A subject either developed a blood clot or didn't. We summarize these data with the sample proportion, p hat, which equals x over n, the number of successes divided by the sample size. A proportion is simply the average of zeros and ones. Let's work through a concrete example. A simple random sample of 57 adults reveals 17 current smokers. The sample proportion, p hat, is 17 divided by 57, which equals 0.2982. We typically report this as 29.8%. The APA publication guide recommends converting proportions to percentages with 1 decimal accuracy. Now here's the key question. How good is our sample proportion at estimating the true population proportion p? If we could draw many samples of the same size and compute p hat each time, we'd get the sampling distribution of p hat. For moderate to large samples, this distribution is approximately normal. Centered right at the true proportion p, the shaded region shows one standard error on each side of p. This normal approximation comes from the binomial distribution. 3 key properties define the sampling distribution of p hat. First, the expected value of p hat equals p. This means p hat is an unbiased estimator of the population proportion. Second, the standard error of p hat is the square root of p times q divided by n, where q equals 1 minus p. Larger samples give smaller standard errors and more precise estimates. Third, the normal approximation is valid only when both n times p and n times q are at least 10. These conditions ensure enough successes and failures for the bell curve to be a good fit. Let's verify the conditions for our smoking example. We have n equals 57 and p naught equals 0.25. n times p naught is 57 times 0.25, which equals 14.25. That's at least 10. Check. N times q naught is 57 times 0.75, which equals 42.75. Also at least 10. Check. Both conditions are satisfied, so the normal approximation is valid for this example. Let's recap. The sample proportion p hat equals x over n, its expected value equals p, making it unbiased. Its standard error is the square root of pq over n, and the normal approximation is valid as long as both np and nq are at least 10.